All right, I'm going to attempt to show you using the block method how to write the electron configuration for phosphorus. We're trying to figure out these 15 electrons in phosphorus, which orbitals they exist. So, start over here. This is the hard method first, but I have to show you the hard method first because this is the book method. Promise to show you the good cheat. Okay, we're going to start way over here at the top left-hand corner. Hydrogen. Hydrogen just has one electron. That would be 1s, the first s orbital. This is the second s orbital, 3s, 4s, and so forth. Over here, helium. Remember, helium is moved over here next to hydrogen, so that's the first and second electrons in the s orbital, and that's 1s complete. Remember, there's 2 electrons in every complete s orbital. So I'm going to write this, 1s2. So I've essentially walked, it's like you're walking through the chart, with the exception that helium is over here. So pretend that helium is over here. We've done 2 electrons, 1, 2. Now where do I go after I finish that first row? Well, I go down here to the next row. Electrons 3 and 4 are represented here with lithium and beryllium. Lithium has 3 electrons. Beryllium has 4. So for beryllium, you would have another complete s orbital. So now we've done 1, 2, 3, 4. We've got to keep walking and keep adding until we get all the way down here to P, phosphorus. This method is a little slow. All right, 1, 2, 3, 4. Now we're going to jump over here. We're out of the s orbital. Now this is the P block. Remember, we can speed this up a little bit by remembering that there are 6 electrons in every p orbital. So I'm going to count 1, 2, 3, 4, 5, 6. That takes me all the way to neon. Neon is atomic number 10. It would have 10 total electrons. So at this point, I can write 2p6. This is neon. We just wrote the electron configuration for neon. Not the answer to the question, but I'm showing you that as you go down the chart, as you go across and down, the electron configurations get longer and longer with more numbers and more letters and more subscripts. Okay, let's check and make sure this is really 10. 1, 2, 3, 4 plus 6 is 10. Okay, but we're not done. We're not actually trying to get to neon. We're trying to get to phosphorus. Well, let's keep going. After you finish this row, you have to go down to the next row that starts with sodium. There's your 11 electrons. So we're going to fill another s orbital. This would be 1s2, 2s2, 3s2. Now I'm all the way to magnesium. Jump over here to the p orbital block, and I'm going to count 1, 2, 3. I did it. I got to phosphorus. Notice this is not a complete orbital. Sometimes they don't have full orbitals. We're going to write the next p orbital, which is to 3p, but instead of writing a 6, I can only write a 3 because I've only put 1, 2, 3 electrons into that next p orbital. Now, the money question is this 15? 1, 2, 3, 4 plus 6 is 10, plus 2 is 12, plus 3 is 15. Yay! That's the electron configuration for phosphorus.